The Harvard Club of Southern California is one of the largest and most active Harvard alumni clubs in the world, and we're delighted to be able to sponsor this event for you. My name is Neil Morgenbesser. I'm Harvard College class of '86 and the director of the Harvard Speak LA program, which brings the opportunity to the broader alumni community for some intellectually and academically stimulating interactions with some of the most stellar Harvard faculty members, and in this case, interstellar Harvard faculty members. We had a terrific event last month with Dr. Loretta Mickley, head of the Atmospheric Chemistry Modeling Group at Harvard, on wildfires in the Western US, which was very topical and well received. Our next scheduled events are Harvard Law School professor Randall Kennedy speaking on his new book, How We Overcame Protest Law and the Demise of Jim Crow, on Thursday, March 20th. And we're going to have a wide-ranging conversation with now retired Harvard government professor Harvey C. Mansfield on Tuesday, April 8th. We also have commitments from English professor Stephen Greenblatt, psychology professor Steven Pinker, and Kennedy School professor Tarek Massoud. So stay tuned for those over the next few months, as well as some more we've got in the works. Today, we are extremely excited to be able to hear from Professor Avi Loeb. Professor Loeb is the Frank B. Baird Jr. Professor of Science at Harvard and a best-selling author of 8 books on a wide range of topics, including black holes, the first stars, the search for extraterrestrial life, and the future of the universe. Professor Loeb is the director of the Institute for Theory and Computation at the Harvard-Smithsonian Center for Astrophysics, and also serves as the head of the Galileo Project. From 2011 to 2020, Professor Loeb was Harvard's longest-serving chair of the Department of Astronomy and was one of the most influential people in space. In 2024, Professor Loeb was ranked number 3 in publication record and impact of research among all astronomers worldwide by Scholar GPS, and his latest TED Talk was among the 10 most popular TED Talks in 2024. Professor Loeb has recommended some supplementary reading materials, a link to which was circulated with the initial invitation, and it's also posted in the chat. Professor Loeb is here to discuss his current research on recently discovered anomalous interstellar objects. Is space trash from extraterrestrial technological civilizations lurking among natural interstellar rocks? Let's find out. It is my honor to introduce Professor Avi Loeb.
Thank you so much, Neil. It's a great pleasure and privilege to join you. And I'm really jealous at the weather in California right now, because I jog every morning at sunrise, and it has been snowing recently here, and it's very cold. But we have to adapt to whatever circumstances we're in. And that will be the theme of my talk, actually, that, we do see a lot of houses in our cosmic streets that look just like ours, the Earth-Sun analogs. And of course, many of my colleagues prefer to suggest that they have no residents in them, but I think it's completely ordinary to imagine things like us, because I don't regard humans as the pinnacle of creation. There is a lot of room for improvement, as I'll try to argue. This is just the conclusion I get from reading the news every day. Yeah. So let me, let me share my screen so you can see my slides, and obviously we will have time for questions. Keep record of your questions. So when I look at the sky at night, I often see a lot of stars, and they look to me like the lights of cabins in a giant ship that sails through space. That's the Milky Way galaxy. And I often wonder whether there are any passengers in those cabins. And about 70 years ago, Enrico Fermi, a very accomplished physicist, had lunch at Los Alamos, and they were discussing extraterrestrials, and he asked, where is everybody? If there are things like us near other stars, why don't we see them around us? And the question, where is everybody, is asked by any lonely person. And what you tell a lonely person is, don't be so presumptuous. You are not that attractive. You should seek others. They will not come to you necessarily. You should go to dating sites. At the very least, look through your windows. And Enrico Fermi didn't build a telescope to look out. he was just wondering why aren't they next to him in Los Alamos. And what is often said about extraterrestrial intelligence is that extraordinary claims require extraordinary evidence. I don't regard something like us as an extraordinary claim, because there are hundreds of billions of stars like the sun in the Milky Way galaxy alone. And at least a few percent of those stars have a planet the mass of the Earth, roughly at the same separation as we are from the sun. So I regard that as an ordinary claim to say, under similar circumstances, you get things like us. And ordinary claims require ordinary evidence. By the way, most of my arguments are relatively straightforward. You know, I regard them as common sense. It's because I was born on a farm, and I never intended or imagined to become a physicist, but circumstances brought me to where I am right now, and I only explain things that I fully understand.
Okay.
Life is very often
Said I will.
sorry,
I'll tell everybody
someone
what
is not
what to
muted.
do.
It is what it is. All we can do is.
Can we mute everyone, please? Yeah. Life is very often a self-fulfilling prophecy, and therefore it's better to be an optimist. If we don't seek
You got muted, Professor Loeb. Can you unmute?
Okay.
There. Thank you.
Life is very often a self-fulfilling prophecy, so it's much better to be an optimist. If we don't seek evidence, we will never find it. I seek a higher intelligence in interstellar space because I have a hard time finding it here on Earth. In fact, you may think of AI as artificial intelligence, but it's also alien intelligence. Both may eventually be found to be superhuman. And it's a good opportunity for us to grow if we find them. And the most important aspect of science is that it allows us to stay curious, because it's a learning experience, and we learn from evidence rather than prejudice. We can have an opinion, but it's not worth much. We should seek data that will educate us about the physical reality that surrounds us. So we should, if we consider the possibility of having neighbors, we should look for them to find out if they exist. Because new scientific knowledge does not fall into our lap. We have to invest time and resources, money, to find new evidence. We had to invest $10 billion in the Large Hadron Collider to find the Higgs boson. We had to invest $10 billion in the Webb telescope to find the first stars and galaxies. And because of that, a couple of months ago, I put a bet against Elon Musk. There was a podcast in which Peter Thiel argued, never bet against Elon Musk following the elections. And the following day, I placed a bet against Elon Musk because he said that we should go to Mars simply to mitigate the existential risk we have on Earth, because we are probably alone, he argued. And I said, based on what we know about the universe, it's very unlikely that we are alone. In fact, there could have been many things like us billions of years ago, and they could have sent equipment, spacecraft, or even just space trash that would have reached us by now, because the Voyager spacecraft would get to the opposite side of the Milky Way galaxy in 1 billion years. So I said I'm willing to put 1% of my net worth against 1% of Elon Musk's net worth in a common pool. That will be about $4 billion based on his net worth. And we will use that money to search for any space trash or functioning devices from interstellar space within the orbit of the Earth around the sun. And in fact, a couple of weeks ago, I wrote a scientific paper that suggests a space telescope that will do this job by looking for objects within the orbit of Mercury around the sun, because the sun is a lamppost, our nearest lamppost, that illuminates the darkness of space, and we can look for the keys under this lamppost. And I said, if within a decade we don't find anything, I'm willing to give Elon another 1% of my net worth. He didn't reply as of yet. If any of you knows him, please encourage him to. I think he's too obsessed with government efficiency. We should think about bigger problems right now. And if we imagine other places within the solar system that may have life, the most exciting possibility, in my opinion, is offered by a moon of Saturn. That will be my favorite destination. If I had one trip to make in the solar system, it would be to Titan, because it's the only other object, in addition to Earth, that has liquids on its surface. The Earth has liquid oceans of water. Titan has oceans, lakes, rivers of methane and ethane. The surface temperature is 94 degrees Kelvin above absolute zero, about 1/3 of the temperature on Earth. And what I would like to do there is go fishing. If I find any fish in these oceans, it will be life as we don't know it. So it would be very exciting. Obviously, I will not eat any of these fish. It may be harmful. There is actually a mission that NASA is expecting to launch in 2028, in 3 years, called Dragonfly, to Titan, but it will have no fishing hooks. What I would like to describe is a project called the Galileo Project, looking for technological artifacts that were manufactured by extraterrestrial civilizations. I established this project, I'm leading it, 4 years ago. And just last week, we celebrated a new sculpture that was donated to my office by the accomplished sculptor, Greg Wyatt. He came from New York City, made a bronze sculpture of Galileo looking at the 4 moons of Jupiter. That convinced Galileo that we are not at the center of the universe, because here they are, points of light orbiting another object, not the Earth, but Jupiter. And so Greg produced this beautiful sculpture, and we celebrated it. It was a wonderful event. He also is donating. I mean, he donated that at no cost. He also donated some watercolors in appreciation of the Galileo Project. And I'll describe it more in the next slides. But let me also mention, in the context of Galileo, what Richard Feynman said. He lived not far from where you are. He was at Caltech, Pasadena. And he said, it doesn't make a difference how beautiful your guess is. He was talking about physics. It doesn't make a difference how smart you are, who made the guess, or what his name is. If he disagrees with experiment, it's wrong. Now, this sounds really simple, but for 50 years, the mainstream in theoretical physics, which is the profession that Richard Feynman mastered, the mainstream containing maybe 1,000 physicists working in theoretical physics over the past 50 years, was dominated by a community of people who focus on an idea that has no experimental verification. Within their lifetime, they cannot envision an experiment that will test their theory. They don't listen to Richard Feynman. They're just trying to show how smart they are. This is called string theory. But they may be completely wrong in describing the physical reality around us. Since there is no experiment, nobody knows. So the key is to address questions that can be tested by finding evidence, by experimental evidence. And sophistication is not the name of the game. You're not supposed to impress other people that you are smart. That's not the goal. The goal is to figure out what reality is. And for that, you may not need mathematics in extra dimensions. It may be sufficient to find a gadget that was manufactured by another civilization. It will change the future of humanity. This will be the most important discovery that science ever made. You don't need sophisticated math for that. You just need to find it. Now, the Director of National Intelligence over the past 4 years reported about unidentified anomalous phenomena. There were 3 reports that led to the establishment of a new office in the Pentagon. These are objects that they cannot figure out. And there are 2 ways to interpret that. Either they are not doing their job, despite the fact that we are investing nearly $1 trillion a year in the defense budget. You know, they're looking at the sky and seeing objects that they cannot figure out. They're not doing their job. That's a serious matter. Why aren't they doing their job for such a huge investment of taxpayers' money? The second possibility is that some of these objects cannot be identified because that they do not represent human-made technologies. So in order to figure it out, based on evidence, we established the Galileo Project. And the observatory that we built first is at Harvard University, and we are basically monitoring the entire sky in the infrared, optical, radio, and audio bands. And we are analyzing the data with machine learning software, artificial intelligence. And what you're seeing here are the different instruments that we're using. One of them looks like R2-D2 from Star Wars. And that's just a collection of cameras in the infrared that cover the entire sky. You can see a more detailed description of that here. And the first phase was to calibrate those cameras in the infrared. And that took us some time. And we now have a paper out that describes the first 500,000 objects that we monitored in the sky over a period of 5 months. And we obviously had to calibrate those instruments and figure out the sensitivity and so forth. And we went through all of that in recent years and built an observatory that is functioning right now. And in total, we are planning to have 4 observatories in the near future. The first one was at Harvard. The second will be in Pennsylvania, the third in Las Vegas. You can see it here on top of the sphere. These observatories in Pennsylvania and Las Vegas will be completed probably by summer 2025, within half a year. And then we are in discussions with people who are building a new campus for STEM education in Indiana, and they want to have a Galileo Observatory there. And I see that as a great opportunity to educate young minds and excite them about science. Because once they become senior practitioners, you know, they are often following other pursuits. They're trying to gain honors, awards, stature, and so forth. But science is all about maintaining our childhood curiosity. And my hope is to deliver that message to the younger generations so they will do science for the right reason. Now, in astronomy, over the past decade, we discovered the first objects from outside the solar system. So it's a new frontier in astronomy, and that's what brought me to this subject. With my student, we discovered an object from a decade ago that was identified by US government satellites. They saw a meteor. The object was roughly 0.5 meter in size, and it collided with Earth at a very high speed. In fact, we figured out that it was moving not only faster than the speed needed to escape from the gravitational pull of the sun, but even outside the solar system, it was moving faster than 95% of the stars near the sun. And the question was whether it's a Voyager-like meteor. Imagine our own spacecraft Voyager colliding with another planet like the Earth. It would appear as a meteor. And then in 2017, there was an object much bigger than that, roughly the size of a football field, 100 meters in size, that passed near Earth. It didn't collide with Earth, but we could see the reflection of sunlight from it. And it was very weird, actually, and I'll say more about it in a minute. And finally, there was a comet that was discovered 2 years later, and it looked just like familiar comets. And so my colleagues argued, well, this comet looks familiar. Doesn't it convince you that the other objects are also natural? And I said, well, if I go down the street and I see a weird person, and after that I see a normal person, it doesn't make the weird person normal. You have to consider each object based on its own qualities. And so Oumuamua was weird. Well, first of all, the name Oumuamua means a scout in the Hawaiian language. It was discovered in Hawaii by an observatory called Pan-STARRS that was trying to find near-Earth objects. You might have heard about the asteroid 2024 YR4 that could have been a city killer, but was recently found not to impact the Earth in the near future. And so it's not a risk anymore. But that telescope was searching for near-Earth objects, and then it saw one that was moving too fast to be bound to the sun by gravity, and so it was identified as an interstellar object. And what was strange about it is the brightness of reflected sunlight was changing by a factor of 10 as the object was tumbling every 8 hours. And that's a big change. It means that the surface area of the object projected on the sky was changing by a factor of 10 every 8 hours, meaning that the object is most likely actually disc-shaped, like a pancake. In addition, the object exhibited a push away from the sun without any evaporation, no cometary tail. It was definitely not a comet of the type that we are familiar with. And so I suggested that the push is not coming from the rocket effect, the way you get it in the context of evaporating comets, but it was just the sunlight reflecting on it that pushed it. Just like an empty trash bag or a broken piece of some technological structure, a Dyson sphere from another civilization. And it turns out that we produced a lot of space trash already. In fact, on January 2nd this year, the Minor Planet Center announced, and that center is actually at Harvard, it announced a new asteroid based on a report from an amateur astronomer. And just a few hours later, astronomers corrected the Minor Planet Center and said that one is actually the Tesla Roadster car that was launched by SpaceX in 2018 as a dummy payload on the Falcon Heavy. It was a technological object, not an asteroid. But it was a near-Earth object because it was launched from Earth. So it's now moving around the sun and will come closer to Earth in the future. And in fact, it may collide with Earth in 20 million years. And obviously, if there are astronomers not aware of that at that time, they might argue that it's a rock of a type that they've never seen before. There are many examples for such confusions. In December 2024, there was an object that was announced by some astronomers as being a dark comet, meaning, which is basically an oxymoron. It's just like saying an elephant is an unstriped zebra. You can't call an elephant a zebra. It's not the same animal. Even if you're trying to dress it as a zebra and say that it's a zebra without stripes, it's not the same nature as a zebra. And therefore calling this object a dark comet is inappropriate, because we showed with my postdoc that it was actually a spacecraft launched by the Soviets back in 1965. It's not a dark comet, it's simply not a comet. And then in September 2020, the same telescope in Hawaii that discovered Oumuamua found an object that they called 2020 SO. They said it may be a dark comet, and it ended up being a rocket booster that was launched in 1966 by NASA. So here you have examples of objects that are pushed by sunlight, some of them, simply because they're technological in origin and have thin walls. The question is, who produced Oumuamua? It came from outside the solar system. And a year ago, I gave a lecture at the hometown of Nicolaus Copernicus, celebrating 550 years to his birth by the Polish government. And the title of my talk was The Next Copernican Revolution, which would mean that not only we are not at the physical center of the universe, but we are also perhaps not at the intellectual center of the universe. We may have a partner out there, perhaps more accomplished than we are. It's possible that Elon Musk is not the most accomplished space entrepreneur since the Big Bang, 13.8 billion years ago. There could have been many more. Most stars, and that is a fact that we know, most stars formed billions of years before the sun. The sun is a late bloomer. It formed only in the last 1/3 of cosmic history. And the Voyager spacecraft will be on the opposite side of the Milky Way galaxy in 1 billion years from now. So there was plenty of time for technological objects to reach our backyard, even if they use the same propulsion technology as Voyager did. And that's old technology for us as well. So I decided to lead an expedition to the Pacific Ocean a year and a half ago to search for any materials left over from the first interstellar meteor that was recorded by US government satellites. And the US Space Command confirmed that this object indeed is of an interstellar origin from outside the solar system at the 99.999% confidence. And so they also released the light curve from the fireball that was created as a result of the friction of this object on air. There were 3 flares separated by 0.2 of a second from each other at an altitude of 20 kilometers above the sea level. And that's very low in the atmosphere. It meant that the object had material strength that was tougher than all other meteors recorded by the US government and appearing in the catalog compiled by NASA. There were hundreds of them, and this one was exploded only in the lower atmosphere, was moving very fast, and must have had the highest material strength. And so that raised my curiosity as to where it came from, actually. And so we had an expedition that was funded by $1.5 million. We went there in the middle of June 2023. This is the team on the deck of the ship that was fittingly called Silver Star. And here are some photos from that expedition. What we did is use a sled that you see in the upper panels in the middle and on the right-hand side. We had magnets on both sides of the sled, and we put it on the ocean floor and went 26 times back and forth across the 7-mile region that was identified as the fireball location by the US government satellites. What you see at the bottom left and middle is me jogging in the morning at sunrise, as I often do on land, I also did it on the deck of the ship. And there was a Netflix filming crew there, and the Netflix documentary is supposed to come out within a year. And they asked to sort of film me when I'm jogging one morning. They actually asked me to jog 3 times longer than I usually do. It was an hour and a half and about 10 miles that I jogged. And at the end of it, the director asked me, Avi, it looks like you're running. Are you running away from something or towards something? And I said, both. I'm running away from some of my colleagues who are not seeking evidence. And I'm running towards a higher intelligence in interstellar space. And we recovered materials on the magnets, and we used the vacuum cleaner to make sure that we don't lose any of that. You can see here. And then we dried up the material and put it under a microscope. And after 6 days, as you will see in the documentary within a year or so, we started finding these molten droplets that were very distinct and different from the grains of sand that they were surrounded by. You can see here one of them at the tip of the arrow, and we picked them up with tweezers. And altogether, we found 850 of them. I brought the materials in this black suitcase. I shipped it by FedEx to my home and then brought it to Harvard University to the laboratory of my colleague, Professor Stein Jacobson, who is a world-renowned geochemist. You can see him on the right side of me, much taller than I am, originally from Norway. And on the other side is Sophie Bergstrom. She was a summer intern working with me, and she found most of the spherules. And she deserves all the credit for that. I called her the spheral hunter. And then we started studying those spherules and trying to figure out their chemical composition, their structure. And you can see here the different types that we found. On the left are spherules that are commonly found from solar system meteorites. And on the right, we found a new type of spherules that was a bit different in terms of its chemical composition. They constituted about 1/5 of the entire sample, and half of them had a very unusual chemical composition. What you're looking at here is the abundance of various elements in the periodic table, and relative to the solar composition, the composition of the material that made the solar system. And we ordered the elements based on their volatility. In other words, elements on the right-hand side are those that can disappear easily during an airburst, during the fireball, a very hot phase of a meteor entering through the atmosphere. And indeed, we're missing them. But the elements on the left appear to have very unusual abundances, up to 1,000 times more than you find in the primitive materials that made the solar system. And these elements in particular include beryllium, lanthanum, and uranium. And we called these fragments that had the unusual abundance, we called them Belau spherules. And here you see 5 of them overlaid on top of each other, and all of them had a high abundance of beryllium, lanthanum, uranium, and that's where Belau comes from. Be is beryllium, La is lanthanum, and U is uranium. And the question is, where did this material come from? It doesn't resemble anything we are familiar with in the solar system, not the crust of the Earth, not the Moon, Mars. So perhaps it's indeed beyond the solar system. It came from some other star. And we also looked at the structure of the various spherules that we found, and we divided that into 4 categories, as you can see here, the 4 columns. And the unusual composition was just in one of those. Now, of course, this kind of material could have arrived from another star as a result of some natural process. And I wrote a scientific paper suggesting one possible natural origin, and that is a planet like the Earth being torn apart by the tide from the most common type of star, a dwarf star. The Sun is not a typical star. The most common star has 10% of the mass of the Sun, a tenth of it, and it also has a tenth of the radius of the Sun. So it's actually much denser than the Sun. The density is the mass divided by the volume, and the volume scales as size cubed. So altogether, the density of a dwarf star is 100 times above the density of the Sun. And because of that, when a planet like the Earth comes close to it, it can rip the planet apart because it's much denser, much more compact than the planet. And you end up spaghettifying the planet, creating a stream of molten rocks. And I calculated the speed by which they will be ejected, and turns out to be very similar to the speed of this meteor that was identified in 2014. So that is a very interesting possible origin for it. But we don't know for sure. And for that, we want to go again to the same site to have another expedition and look for bigger pieces. And here is a picture from the last day of the previous expedition. I'm standing next to Art Wright. He was a commander of a destroyer during the Vietnam War, and he was the navigator, the chief, the party chief on the ship. And I really liked him because he reminded me of my father. He didn't say much, but everything he said was true. So the hope for the next expedition is to use a much better set of equipment. We are now seeking funding for that. We need $1 million for down payment to this beautiful ship that is called Nautilus, that operates a robot, a remotely operated vehicle that you can see it on the left. It will have a video feed, and we will put it on the ocean floor, and if we get the funding, and be able to seek bigger pieces. We will look at what we're picking up, unlike what we did before with where we used the magnetic sled, that we were blind to what we are picking up. Here we would see if there is anything left from the wreckage of that meteor. So we could potentially go there in August this year if we get the funding. Another reason to be excited about 2025 is the Rubin Observatory in Chile that was funded by the National Science Foundation, and it will start operations within half a year or so. And it employs a camera that you see here that includes 3.2 gigapixels. That's about 1,000 times more pixels than your cell phone camera. And it will survey the southern sky every 4 nights and has a good chance of finding an Oumuamua-like object every few months. So if we find more family members of Oumuamua, perhaps now with the help of the Webb telescope, we can figure out their nature, whether they're technological or natural in origin. And no matter what we find, we will learn something new. So 2025 is likely to be a very exciting year. I hope you will follow what we discover, and I'll be delighted to answer any questions you might have. Thank you.
Yeah, well, thank you so much. That was very, very interesting and very provocative. If people do have questions, please enter them in the chat if you can, or if you want to do it orally, you can raise your hand and I'll try and call on you. But let me start with some of the ones that were submitted as Professor Loeb was speaking.
By the way, you can ask me anything about any aspect of the universe. I worked on many different aspects of So if you have any urgent question about the Big Bang, black holes, anything, don't hesitate. Go ahead, Neil.
Yeah, thank you. So the first question is relative to life elsewhere in the solar system. What about Europa and or Enceladus?
Yeah. So one thing we know about Enceladus and Europa, both are moons. One is of Saturn. Europa is of Jupiter. Enceladus is of Saturn, and both of them have geysers. They have icy surface. So in Europa, it goes down at least 50 kilometers. There is a huge layer of ice, but there are cracks in the ice in both of them. And it looks like, especially in Enceladus, there are plumes of water vapor coming out of those cracks. And potentially, we could fly a mission. NASA is, and also a private organization, are considering going there and searching for any complex biological molecules in the water vapor. That would be really interesting to find. We don't know if there is life under the ice. If we came very close, maybe we would see some dead fish on the ice.
Mhm. Okay. Do you think that any particular EM band is more likely to produce evidence of extraterrestrial life than others?
Well, that was the traditional approach that was pioneered by Frank Drake 60 years ago. And the idea was we just developed back then radio communication. And the interesting question is, could we detect radio signals from other civilizations? And it was worthwhile checking for 60 years. We haven't found any signal. But the way to think of this is just like listening to a phone call, waiting for a phone call. Nobody may call you when you're waiting. And we've just been monitoring the sky, in fact, a small fraction of all the stars in the sky, for about 60 years, which is a tiny fraction of the age of the universe. And if there was a signal that was transmitted 1 million years ago, it's now 1 million light years away. So the alternative that I'm suggesting is looking for packages in our mailbox or in our backyard, looking for a tennis ball that was thrown by a neighbor. Those spacecraft that we launched to interstellar space are not moving very fast. They're moving 10 times slower than the speed needed to escape from the pull of gravity of the Milky Way galaxy. So they would keep accumulating over time, just like plastics in the ocean. And all we need to do is look for them. And a couple of weeks ago, I wrote a paper of if there was $1 billion to be used for a telescope that would search for space trash, then the best thing to do is look for it close within the orbit of Mercury around the sun. The sun is just a lamppost that illuminates the surroundings, and we can see those objects even with a 1-meter telescope. And I calculated that there should be one interstellar object of 10 meters in size entering within the orbit of Mercury every 5 hours. So there should be plenty of them that we could monitor and check if there is anything technological, any empty trash bags among the rocks that are coming into the solar system from other stars. And that would be very interesting to figure out. But it's a different approach than waiting for a radio signal.
My question on all this is, if we go from a situation in which the numbers are zero, and this isn't happening, to the numbers are billions, and this is happening, why is the prevalence so low? It sounds like there should be
it's
lot.
because, yeah, there should be a lot, but space is huge. The volume of the Milky Way galaxy, the size of the Milky Way galaxy is tens of thousands of light years. If you consider the disk of the Milky Way galaxy, it's actually hundreds of thousands of light years if you consider the halo of the Milky Way galaxy. That's a huge distance. even light takes tens of thousands of years to cross the entire Milky Way galaxy disk, you know, and so because of the enormous volume that is involved, things are diluted, you know, and you know, with the best telescopes we have right now, we can barely see the reflection of sunlight from an object the size of a football field, 100 meters in size, which is bigger than Starship. You know, our biggest rocket currently is Starship, and that is smaller than 100 meters. So even if you had an extraterrestrial starship flying within the orbit of the Earth around the sun, in other words, coming very close to the sun, we would barely see it, not to speak about it flying in the much bigger volume of space that surrounds that region. You know, the distance to the nearest star is 4 light years, and there is a huge volume there. I mean, about a quadrillion times bigger than the volume associated with the orbit of the Earth around the sun. So it's just a huge dilution factor, and unless you have objects that are functioning, that are seeking Earth and coming closer, if you are just relying on chance appearance of objects, you really need to look hard to find them. And we found some interstellar objects. 2 out of 3 were unusual, and I'm saying, let's find many more. And you know, with existing survey telescopes, we can't detect objects smaller than 100 meters. We need additional funds at the level of $1 billion to do that.
Got it. Okay, I'm going to keep going. These questions jump around, but you can seem to handle it. So I won't look for thematic consistency. Dr. Loeb, decades ago, my sister took an extraterrestrial course at Northwestern from Dr. Alan Hynek, the technical advisor and inspiration for Close Encounters of the Third Kind. As a fellow academic, what is your assessment of Dr. Hynek's work?
I mean, so he was studying unidentified, what we call now UAP, what used to be called UFOs, and he was taking it seriously, and he was looking for evidence. And I should say nothing is conclusive as to the evidence that was presented publicly. And one possibility is that the US government has classified information. I'm not signed on any non-disclosure agreement with the US government because I want to protect my freedom at discovering things. You know, if I were to know about something the US government has that is classified and I will discover something similar, I would not be able to speak publicly about it. The sky is not classified. And so in principle, we could see things if they are out there. The fundamental question is, does the US government have materials or information about objects that were manufactured by extraterrestrial technological civilizations? And it's possible there were some people testifying under oath in recent years that, in fact, there are programs for retrieval and reverse engineering of such technologies. And maybe, you know, the objects that were discovered by the US government are currently held by corporations like Lockheed Martin. I simply don't know if that's the case. If it is, I would argue that it's not a matter of national security. I mean, the US government day job is national security. My day job is what lies outside the solar system. We shouldn't rely on the US government to tell us what lies outside the solar system, for the same reason that you shouldn't rely on the Vatican to tell you whether we are at the center of the universe. You know, the Vatican admitted in 1992 that Galileo was right. That was 350 years after Galileo died. It was 2 decades after humans reached the moon. It's a little late for them to admit that. And, you know, the US government has all kinds of political reasons to avoid discussing things that were, you know, data that was collected by classified sensors or data that they cannot understand because perhaps it was, you know, these objects were manufactured by adversarial nations. Therefore, we should not tell them, you know, what we know and what we don't know. So this, you know, if the government has something that they know for sure was not human-made, I think they should share it with scientists like myself, because this is something to do with our neighbors. And, if you have family members and you go out to the backyard and you find a tennis ball that was thrown by a neighbor, I mean, you have two options: either to tell your family members at the dinner table that you found something that demonstrates that we have neighbors, or to hide it. I say that it's a bad practice to hide it from your family members, because one day the neighbor would appear in the backyard. It's better for us to be aware of the reality that we all share. I mean, the delay tactics that was adopted by the Vatican was not a wise move. I mean, obviously, Galileo was put in house arrest. He wasn't able to communicate freely his ideas, and it took hundreds of years for the general public to accept his view. But in the long run, this is just delay tactics. If we have neighbors, we better know about it, because we can adapt to that reality the same way that we adapted to the reality that we are not at the center of the universe. Nature is under no obligation to make us happy. So some of the facts that we discover about the universe, about the reality, may not be flattering to our ego. We are not at the center of the universe, even though we want it to be. But so be it. We can reach Mars right now because we understand that Mars is not orbiting the Earth. If the engineers in Pasadena, in the Jet Propulsion Lab, were to believe in the dogma that the Vatican was manufacturing, hundreds of years ago, then they would send rockets towards Mars that would never reach the destination, because the model was wrong. Mars is not orbiting the Earth. And so my point is, it's much better to admit reality, even if it's not flattering to our ego, because then we can adapt to it and we can accomplish our goals. And if we have a neighbor, it's better to know about it.
What's the update on signals intelligence like the original SETI project?
The update is they haven't found any signal.
Okay.
And I should say also, they are very hostile to alternative methods. So they do not want to discuss objects near Earth that might be of technological origin.
Is that a bureaucratic sciencey thing, or is that something different?
No, it has to do with the fact that the public is very excited about this possibility, and they want to show that, they are not attending to arguments made that were unsubstantiated. Many people in the public just make all kinds of statements based on science fiction stories or on arguments that, that are not substantiated. And the SETI community is taking the wrong approach of simply ignoring this subject altogether.
Okay. In looking for extraterrestrial life, wouldn't we be far more likely to find viral-like objects or unicellular organisms than intelligent beings? And if
Yes.
there were extraterrestrial life looking for life, wouldn't it take them an incredibly long time for them to find us?
Yeah, so there are two aspects here. And the mainstream of the astronomy community is basically following this narrative, saying, as soon as the Earth cooled, microbes appeared. And these are primitive forms of life without intelligence. So microbes must be far more common than human-like entities, intelligent beings, which is probably true. But the point is that to find evidence for microbes, the current plan is to build the Habitable World Observatory that will cost more than $10 billion and will only be completed after the 2040s. That's the recommendation of those people who say that microbes are probably much more common. Let's search for the molecular fingerprints like oxygen, methane in the atmospheres of exoplanets, invest $10 billion in searching for those, for oxygen and methane, as the first priority, and not and completely marginalize the aspect of intelligence. And I say, well, first of all, oxygen, methane, or other molecules could be manufactured by other processes that are natural in origin without any life being involved. You could have rare geological processes that would give rise to those molecules. And moreover, if there happened to be a technological signature that we detect, it would be clear beyond any reasonable doubt that we have discovered not only life, but intelligent life. So let me give a few examples. If we discover industrial pollution of the same atmospheres of those planets, we find CFC molecules. Instead of searching for oxygen, we'll find the molecules that we are producing by refrigerating systems in our industries that nature never produces. These are very big molecules called CFCs. And if we find them, instead of seeking oxygen, if we find those, we know that there is industrial life out there. Okay? These would be, beyond any reasonable doubt, signatures of life, because nature doesn't make these molecules. Now, if I go to the Pacific Ocean and I find a gadget in the wreckage of the meteor, and it's a technological gadget, then it will be clear beyond, and humans could not have produced it. It will be clear beyond any reasonable doubt that there is intelligent life out there. So what I'm trying to say is, even if microbial life is much more common, much more abundant, the signatures of the microbial life are difficult to find and also somewhat ambiguous. And they would cost more than $10 billion to find. However, searching for technological products, even if they are not as common as microbes, might be much more conclusive, might be easier if it's in our backyard. And as I mentioned, it takes 1 billion years for objects like Voyager to reach us from the other side of the Milky Way galaxy. And most stars formed billions of years before the sun. So the issue of travel time is not really an issue as long as you're not thinking about delivering living creatures in those vehicles. I mean, now we are developing artificial intelligence. There is no reason to send humans to interstellar trips. You can just send technologies with artificial intelligence that would make decisions on their own, will be autonomous. There is not enough time for them to communicate with the senders anyway. So that would be the most natural thing to send, the technological object with artificial intelligence.
Do you, Professor Loeb, have another 15 or 20 minutes to keep going with these questions? Because we've got about half a dozen more.
I have about 12 minutes, yes.
Okay, let me do a rapid fire one. We'll do quick question and answer. When we find definitive proof of extraterrestrial intelligence or other planetary civilizations, how do you believe humanity should respond?
Oh, it all depends on the properties of the visitor. Before you decide how to respond to a visitor, you have to speak with, you have to figure out what the intent of the visitor is, what the qualities of the visitor are. I had one day, my wife saw a man standing on the street and looking at our house. And she said, that person has been looking at our house for an hour, and I'm worried about him. He may be one of your fans. Why don't you go out and check who that person is? And so I went and asked him, why are you looking at our house for an hour? And he said, I used to live in this house 50 years ago as a kid. And so I invited him to the backyard, and he said, we buried a cat in the backyard. The cat's name was Tiger. And I said, I know this name because I saw the tombstone, and I hope that it's not a real tiger buried under the tombstone. And so what I learned from that experience is that, I would have never imagined the intent of that person unless I spoke with him. And of course, the response should reflect the intent and the qualities of the visitor.
Okay. Is there a chance of life in the atmosphere of Venus? Yes.
I mean, there are some scientists, some that are close to Harvard at MIT. Sarah Seeger used to be a student. In fact, I was on her thesis committee when she graduated from the Harvard Astronomy department. And And she is involved in a study that claims that we see phosphine in the atmosphere of Venus, and that could indicate, I mean, phosphine is produced on Earth by life in the oceans, and she imagines, even though the ground is very hot on Venus, there could be droplets in the atmosphere, in clouds, that about 50 kilometers above the ground, that could potentially have bacteria that produces phosphine. And she is currently engaged in designing a mission that will go to Venus and go through the clouds and try to scoop them and see if there is any life there.
Okay. When do you expect isotope dating to begin, and what do you expect to learn from isotope dating?
An excellent question. We had a meeting last week. I needed funding to continue the analysis, and so I wrote to one of my funders. I said we need $300,000, and within the following morning, I had an email saying you have the money. And so we are funded for at least the next 12 months to use Stein Jacobson's laboratory and his research assistant, Eugenia Young. And we will definitely do the isotope analysis. And that's thanks to the generosity of our funder, Eugene Zhong, who lives not far from you in Palo Alto.
Is there a possibility of a wormhole that would allow you to travel from one area of the galaxy to another?
So to make a I mean, the idea of a wormhole started with Albert Einstein, who wrote a paper together with Nathan Rosen in about, let's see, 90 years ago. And turned out that the kind of wormhole so a wormhole connects two regions of space in a way that allows you to travel from one region to the other faster than light, because you're not going through the normal space that we usually see, but there is this underlying wormhole, that sort of a tunnel that gives you faster. I mean, the way to think of it is, suppose you were to only think about the surface of the Earth, and you can go from the US to Australia, just hovering above the surface of the Earth like an airplane does, and it will take you a long time. But if you were to dig a tunnel through the center of Earth, you will end up in the Indian Ocean, close to Australia, on the other side of the globe. And if you just go through that tunnel, even without propulsion, you can, just using gravity, get there within 38 minutes. And so that's the idea of a wormhole, that it could be a structure of space-time that connects two spatial regions and allows you a fast transition between them. But it turns out that the wormholes that Einstein and Rosen were thinking about are not stable. They basically pinch off faster than it takes even for a particle moving at the speed of light to go through the wormhole. So you can't really transit those wormholes. And then it turns out that if you want to build stable wormholes, you need to use material that has negative mass. So we are all used to positive mass that induces attractive gravity. But in principle, you can imagine negative mass that will have repulsive gravity. And to make a stable wormhole, you really need material that has very exotic material that has negative mass. We don't know of such material that we can engineer. I mean, we know that the vacuum itself could be manipulated in that way. I mean, the universe is accelerating. There is some repulsive gravity, but we don't know how to use it to make a wormhole. So at the moment, the popular view is that wormholes do not exist. The one thing to remember is, if you had negative mass to make wormholes, you would be able to also create time machines, meaning you can go back in time. And that's a serious issue, because, if I had a time machine, the first thing I would do is go back to the Second World War, before the Second World War, and attempt to kill Hitler. because that would have saved the lives of 6 million Jews. The fact that nobody did that means that probably there is nobody in our future that was able to travel back to the 1930s. We don't see people from our future. And so until we are able to build a time machine or see evidence for a time machine, probably we should conclude that negative mass does not exist. A material with repulsive gravity cannot be engineered, and therefore wormholes also do not exist.
Okay, two more. With present technology and better funding, what's the best transit time we could achieve to Alpha Centauri with useful mass for instruments and communication? Is that something we should be doing?
Yeah, so in fact, I chaired the scientific advisory board for a project that had this in mind. It was funded by Yuri Milner, who currently lives in Los Angeles. He came to my office at Harvard, sat on the sofa and asked me if I'm willing to chair a project that would aim to send a small probe that will communicate with Earth to the nearest star within our lifetime, meaning within 20 years. And since the nearest star is 4 light years away, that meant that the spacecraft needs to move at a fifth of the speed of light. And 6 months later, the only technique that I could envision that would do that with my students and postdocs was that of a light sail, basically pushing a sail with a very powerful laser beam. And that was called the Starshot, the project. And we studied what kind of sails can be used. The entire weight of the spacecraft would be a few grams. The laser would have to have something like 100 gigawatt power and shine on the light sail for a few minutes. And it could bring it to a fifth of the speed of light. And one can put a chip with communication abilities, so that when it gets to Proxima Centauri, the nearest star, within 4 light years, and that would take, the journey would take 20 years, we would get the communication signal from there. But we only worked out the basic details. The technology is not yet available for that.
Okay. All right. Finally, do you have any opinion on all the drones that appeared in late 2024 around the world? And are they still visible at this time? And any speculation on that?
Yeah, so most recently, last December, there were drones in New Jersey. And all the reports mentioned their flight characteristics be similar to drones. You know, if it looks like a duck, it's a duck. So I was not particularly excited about it. And actually, the President Trump, I mean, the White House made a statement about those. They looked into it, and they said that based on the information from all agencies, it looks like these were all recognized drones from either FAA or private citizens. There was nothing from an adversarial nation, and nothing beyond human-made technologies.
Got it. All right. Well, again, this has been fantastic. I really appreciate the quick answers to all the rapid fire questions. It was a fantastic set of questions too from the audience. I think we got really good engagement. So we really appreciate your taking the time. It was educational, it was insightful, it was provocative, and it was disturbing. So thank you for all of that. And we really just want to express our appreciation for having taken time out of your evening to spend with us here in California. Please come visit when you're out, and we'll be happy to meet you in person or host you for any events. But keep up the work, and anything we can do as an alumni community to support your efforts, we're here for you.
Thank you so much. And California is a place that takes a much better advantage of the existence of the sun than the Boston area. I mean, while the sun lasts, you know, the sun will disappear in 7.6 billion years. So enjoy the sun for now. And if anyone is interested in more details about the expedition, we are seeking a funder. If you know of someone that might be interested in either joining us or in the findings from that expedition, let me know.
Excellent. All right. Well, thank you everybody for joining, and thanks again to Professor Loeb for doing this. We'll see you on the next one. Take care.